volume is on. Okay, so section 7.5. Okay, so this chapter is going to give us yet another tool for solving integrations that involves partial fractions. Does everybody remember partial fractions from last year? Okay, so remember that when we're dealing with partial fractions, we have two polynomials. So we have p of x over q of x. And the important thing to remember is that q of x has to have a higher order than p of x. Okay, so it can be x cubed plus x squared plus 4 divided by, but then the thing in the bottom has to be at least x to the 4th. It's got to be at least 1 power higher, okay, or the whole thing will not work. Now, did everybody do the journal? Do I need to do, if you can't do the partial fraction part, it's silly to do other things. So should we review one of the partial fraction things? Is there one from the journal in particular? Not just any journal question, but a partial fraction. Like number 3 is partial fraction decomp. 7 is partial fraction decomp. Sure. Should we do number 7? We okay with doing number 7? Okay, then let's do number 7, which is page 373. And it just says evaluate the integral, right? So our integral is 2x cubed over x squared minus 4 dx. Okay, so you have come to an integral. You must ask yourself some questions. Do you know what the antiderivative is? No, I don't know what that is. Okay, what's the next question you ask yourself? U substitution. U substitution going to help you? No, because what would you let u be equal to? You might let it be equal to x squared minus 4 because it's in the denominator, but what's that going to do to the numerator? Not really going to help. Okay, what's the next thing that we do? Integration by parts. But integration by parts is really inverse product rule, and we don't really have an inverse quotient rule. You could try to like rewrite that as 2x cubed times x squared minus 4 to the minus 1, but I think it's going to be a long, arduous path. So, hang on. We're getting there. Okay, so we can't use integration by parts. So the only other tool we have in our toolbox is partial fraction decomposition, or as I like to call it, partial fraction decomp, just because it's more fun. Okay. So the problem is, though, as Zoe pointed out, that my p of x, which is 2x cubed, has a higher order than my q of x, which is x squared minus 4. So I don't meet the criteria for that either. But what should I always do or consider every time I try to solve any kind of problem in calculus? What's always an option? Graphing is a good idea. Probably not going to work here, although perhaps, well, it's an indefinite integral. Numerical integration might help. Sarah, what did you say? Manipulating it. And what is the $10 word for manipulating it? What? Algebra. We could do algebra. Okay, and manipulation isn't generally a $10 word, but it is not the $10 calculus word. Okay, so I could manipulate this. Usually I get a groan for what I'm going to do next. What is this symbol usually, what does that symbol mean? Divide by. So this is really 2x cubed divided by x squared minus 4, right? See, this is where the groan comes. So this is really 2x cubed divided by x squared minus 4. See, you did not disappoint. Okay, remember how we talked about that calculus is the culmination. It is the end point of every math you have ever done since you learned how to count. Okay, this is where it all comes together, and this is only the beginning. Well, good, then there's a preview. All right, so it's long division. You can do long division. Seriously. So, how many times does x squared go into 2x cubed? Thank you. 1. The heck did that come from? Jeez Louise. I'm sending you back to 5th grade. And I'm not even sure it was 5th grade because I don't think Graham's done this yet. At least I have, that's Leo. Okay, yeah, I'm pretty sure you did do it last year. Okay, so remember when we're doing long division, we multiply around. So 2x times 2x squared is 2x times negative 4 is minus 8x. Remember that you're subtracting, so you have to go through and change all your positives to negatives and all your negatives to positives. This goes away, and what am I left with? 8x. So, what this means is that 2x cubed over x squared minus 4 is equal to 2x plus 8x over x squared minus 4. If, yes, I have that right. Okay. It's a remainder. Okay. So we're just going to write this again. All right, so what I have is 2x cubed over x squared minus 4 dx. This is going to become the integral of 2x plus 8x over x squared minus 4 dx. And remember that integration, like differentiation, distributes. Okay, so this is really two integrals. It's the integral of 2x dx plus the integral of 8x over x squared minus 4 dx. Well, and first of all, if you look at the integral of 2x dx, can you solve that by inspection? And what is it? X squared. And then I have this. Now, you ask yourself again, can I integrate that by inspection? No. Use substitution. Really? What would you let u be equal to? Priya, what would you let u be equal to? So my integral here would become the integral of 4 over u du. Right? We're getting there. Okay. So I can pull out that 4. So what I really have is du over u. In fact, we'll even write that down. And can I solve the integral of du over u by inspection? I just pulled the 4 out. And so what's the integral of du over u, Gianni? No, not u, when it's 1 over u. I got it. Take a deep breath. Nope, it's special. It's one of the special ones because when I take the derivative of something, I always get 1 over u or 1 over. Yeah, but I want to take the antiderivative of 1 over u. Alf had it too. It's okay. I put you on the spot. Plus c, for my friends who can't remember to put plus c. Okay. And then as Zoe said, we want to make sure that we substitute back in for u. So really, you didn't need partial fraction decomp, bless you, partial fraction decomp to do this. But we're going to do it that way anyway, just for giggles, okay? And practice. All right. So everybody got what they need from here? All right, so let's back up. So the integral I have is 8x over x squared minus 4dx. And remember, the goal of all of my tricks, all of my tools, is to turn the integral into something that I can integrate by inspection. That I can just look at it and go, oh, hey, inverse tangent. Okay, that's my goal. So I want to turn this, my integrand, into something else. And so the first thing that I have to do is factor my denominator. So what does that factor into? Okay. So a big part of partial fraction decomp is undoing the part where you found a common denominator. Okay, because what I have right here is a common denominator, but I don't want one anymore. I want to undo the common denominator thing so that I've got something over x plus 2 and something else over x minus 2. Okay. And then what you do, though, is in order to figure out what A and B are, is I actually find the common denominator again. Which means I have to multiply A by x minus 2. And I have to multiply B by x plus 2. Right? Everybody with me? Everybody remember? Okay. And that's equal to over here, x over x minus 2 times x plus 2. No, I don't know what A and B are. I'm not done. Nor have I solved my integral, which was my whole point. Okay. So once again, transport yourself back to last year, or really anything you've ever done with me. If the denominators are the same, then the numerators have to be the same too. Right? Okay. And then I'm going to do the algebra. So this is going to give me ax minus 2a plus bx plus 2b. And if these two sides of the equation are equal, which they are because there's an equal sign and that's what it means. Okay. And this is what I would term a life skill, which means it's one of those techniques that you can use in many different places. Okay. The coefficients of the x's on this side have to equal the coefficients of the x's on that side. Hang on. And the coefficients of the constants on this side have to be equal to the constants on that side. Which is why I wrote plus 0. This, although you would never, when you're doing partial fraction decomp, have sines and cosines, the same thing works for sines and cosines. The coefficients of the sines and cosines on this side of the equation have to be equal to the ones on the other side of the equation. The imaginary part of this side of the equation has to be equal to the imaginary part on the other side of the equation. It's a way to take an equation, a single equation that has two unknowns, and break it into two equations for my two unknowns. Okay? Not magic, math that you don't understand yet. I used that with my Cub Scouts. So, 0, which is my constant on the left side, has to be equal to 2a plus 2b. I'm sorry, negative 2a plus 2b. No. Okay. So if I play around with this, that gives me 2a is 2b, or a is equal to b, which is probably important. Okay. So those were the constants. I'm going to do the same thing with the coefficient of my x's. So on the left-hand side, the coefficient of my x's is 8. And on the right side, it's a plus b. Lo and behold, two equations, two unknowns. Okay. I know that a is equal to b, so I'm just going to solve for a. So I have 2a is equal to 8, or a is equal to, so a and b are both going to be equal to 4. Okay, so hang on. No, I'm not done yet. Remember this from last year? Coming back to you? Yes, that's why you did use substitution. And in a high pressure timed situation such as the AP Calc exam, you would do the thing that was easiest. But we still need to practice how to do partial fraction decomp, so we're going to. All right, so the danger in doing a multi-step problem is that you forget that you're not done yet. Okay? So remember that all the way up here, what I was trying to do was simplify that integral. Okay, so that means that my integral, which was 8x over x squared minus 4 dx, is now 4 over x minus 2 plus 4 over x plus 2 dx. Right? I'm winging it here because my notes are over there. Okay. So I can pull out this 4. 1 over x minus 2 plus 1 over x plus 2 dx. Remember that the point of all of my tools is to turn this into an integral that you can evaluate by substitution. Not substitution, inspection. So if you look at this, do you know what the antiderivative is of 1 over x minus 2? Maddie, what is it? There is probably a universe in which we should turn those into absolute value signs just because it's a natural log and who knows what x is, but I'm not going to worry about it. What is the antiderivative of 1 over x plus 2? Bless you. Yep. Probably. No, I'm not done. Yes. Okay, so just so that I can get an answer that looks like the answer that I had before, what can I do when I add two natural logs, Maddie? Yeah, it's like multiplying what's inside. I don't know where all my things have gone. Yep, so that gives me the natural log of x squared minus 4. I'm going to put my c all the way at the end, but thank you. Hang on. The x squared is not part of the integral that I'm solving. I need that x squared, but it is not part of what I'm doing right now. Okay. All right, so everybody got what they need off of here? We good? Okay. So, again, my original integral looked like that. I ended up with x squared plus my integral of 8x over x squared minus 4 dx. And we just figured out that that integral was 4 natural log x squared minus 4 plus c. And that is, in fact, the same answer that we got when we did substitution. I do not know how to use your calculator to do the decomp. If it's a definite integral and it is a section and you are allowed to use your calculator, you can always pop it into your calculator, and your calculator will use MRAM, RRAM, LRAM, trap, Simpson's rule, whatever it wants to do, whatever it thinks is best. Okay. So I'm not going to do the example I was going to do because it's the same thing. So we'll try that another time. But actually, yeah, we'll try that another day. Okay. But there's a point to doing this. It is a technique, but there's also an application, which is the logistic differential equation. You'll need a new notebook. Okay. And the logistic differential equation models population growth that looks like this. And actually, I think that's supposed to be T. And this is probably P for population. Okay. So that you start off with some initial population, you end up with a population that's kind of steady, and then there's this period of growth in the middle. And if you look really carefully, I'm pretty sure there's an inflection point in there in the middle somewhere. Okay. Okay, so this is modeled by something that looks like that. We're getting there. Okay. So in real life, the population reaches what's called a carrying capacity. Which is M. And that carrying capacity happens when dp dt goes to 0, which is what we're talking about up here. When the growth levels off, there is in fact no more growth, or if there is, it's very, 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 very small. Where kind of the growth and the, where everything kind of balances out. And in reality, you're kind of, I think you'll do a problem where you actually look at like the number of lowland gorillas that can survive in a preserve. And of course, in the real world, what's happening is you're balancing how many gorillas are born, you're balancing how many gorillas die, you're balancing what the resources can carry, you're balancing how many gorillas are going to survive to adulthood, how many are going to get angry and kill each other once they become adults. So you're balancing all these things. So like Zoe alluded to, the equation is often rewritten as dp dt is equal to kp times that carrying population minus the population at any time. And we are told, because solving it can be a little hard, but we'll get there, is that the answer to this is m over 1 plus a e to the negative mk t. Where, again, m is that carrying population, k is that growth constant effectively, and a is a constant that you will probably have to figure out. Okay. So I'm not going to do, I have a couple of problems that I want to do that involve this, and we will do those tomorrow. And if I were you, I would practice a couple partial fraction decomps off of that packet I gave you, just to make sure that you feel comfortable with it and you're ready to go. And I think there's actually a whole page that just says partial fraction decomposition on it. There should be one. Maybe not. There should be one in there somewhere. Okay, so, you know, I would practice a couple of those over the next couple of days just to make sure you're ready. All right. So the homework is due on Wednesday. I think we'll finish this chapter tomorrow. The test is on Thursday because I wanted to get it done before you all went off on your long weekend, if that's where you're going.